Okay, welcome to this Edexcel Paper 3 video. We're going through the higher tier paper. Follow along, we're going to go through all the worked solutions of the June 2022 paper. Let's get straight into it. Okay, the first question in the paper, let's try to keep a good pace. So we've got a triangle here, and we're asked to work out the value of x, where x is this side over here. So immediately you're seeing a right angle triangle, you're missing a side, you should be thinking Pythagoras, okay? So Pythagoras, the formula, if we apply it here, should be 4 squared plus x squared is going to be equal to 8.5 squared. So then you just need to rearrange for x. So let's rearrange for x squared first. So x squared is going to be equal to 8.5 squared minus 4 squared, okay? And so therefore x is just going to be all of that square rooted, okay? So if you put that into your calculator, you should get 7.5, okay? So we'll put that as our answer, that x is going to be equal to 7.5. Okay, let's move on. Question 2. T equals 4m squared minus 11. Work out the value of t when m equals minus 3. So a simple substitution. We've got the formula given to us already. So all we need to do is plug in. Okay, so we do 4 multiplied by minus 3. We'll put it in brackets. We're going to square all of it. Minus 11. So minus 3 squared is going to give you 9. Then you do 4 times 9 and you minus the 11. So if you put that all into your calculator, you should get that t equals 25. Okay. Part B then, make p the subject of the formula d equals 3p plus 4. So again, just rearranging here. So let's try and get p on its own. So first of all, let's take off the 4 and you get 3p. And then you just need to divide everything by 3. So p equals d minus 4 over 3. Nice and simple. Question 3 then, Rick, Selma and Tony are playing a game with counters. Rick has some counters. Selma has twice as many counters as Rick. So let's underline because we've got a lot of words here. So Selma's got twice as many. Tony has 6 counters less than Selma. In total, there are 54 counters. The number of counters Rick has to the number of counters Tony has is 1 to p. So they're giving us a nice ratio here. Work out the value of p. Okay, so to solve this, basically we want to write them all in terms of one common algebraic symbol. So we say that r is going to be equal to n, okay, where r is the number of counters Rick has, and we're going to call that n. So that means we can then write the number of counters that Selma has and Tony has in terms of n, okay? So we know that Selma has twice as many counters as Rick, so therefore we know that Selma is going to have 2n counters, okay? And we know that Tony has 6 counters less than Selma, so therefore we know that Tony is going to have 2n minus 6 counters, okay? So basically that's what you get. Then we know the last one we need is this statement here, that the total is 54 counters. So if you add all these up, we should get 54. So we can write that as an expression as well. So you get n plus 2n plus 2 plus 2n minus 6 is equal to 54. Now, very simple. We've just got a basic linear algebra equation where we can solve for n. So if we collect the like terms, we've got 2n plus 2n, that's 4n, plus another n is 5n. So 5n minus 6 equals 54. And therefore, n is going to be equal to 54 plus the 6 divided by 5. And you should get that n is equal to 60 over 5, which is going to give you 12. So now that we know what n is, we can just come back to the equations we made at the beginning. So we want this 1 to p, okay? So p is basically, well, this is a ratio, right? So we need to work out how many counters Rick has and how many counters Tony has. And then we can simplify it down to a ratio. So the ratio would basically be n, because that's the number of counters Rick has, to the number of counters Tony has, which is 2n minus 6. Now, we can't simplify it down in this version, so we're just going to plug in our numbers if we know that n is 12. So we know that 12 to 2 multiplied by 12 minus 6 is the ratio, and that comes out to 12 to, that 2 times 12 is going to be 24, 24 minus 6 is going to be 18. So that is your ratio, 12 to 18, but it's not in its simplest form. And actually, you want to get it in the form where it's 1 to p. So you need to make this 12 a 1. So you need to divide through by 12. Okay. So we'll just come down here. So I'll just write it out again. So 12 to 18. And to get this into the 1, you need to divide by 12. So this becomes 1. And then this becomes 18 over 12. Okay. Very simply. And then you can work out what 18 over 12 is. You should get 1.5. Okay. So 1 to 1.5. And that's your final answer, where p is then going to be equal to 1.5. Let's move on. Right, question 4. Joe is going to buy 15 rolls of wallpaper. Here's some information about the costs of rolls of wallpaper from each of 2 shops. chic decor and style paper. Joe wants to buy the 15 rolls of wallpaper as cheaply as possible. Should Joe buy the wallpaper from chic decor or from style papers? And we've got to show our working. Okay, so chic decor is telling us to get 3 rolls for £36. Style papers, 5 rolls for the normal price of £70. But that you get 12% off of the normal price. Okay, so essentially we need to work out the price for each one. So she needs 15 rolls. So it's quite simple, to be fair. So let's check chic decor first. So CD, and I'll go back to my black pen for this. So 3 rolls for £36. So she needs a total of 15 rolls, right? So 15 over 3 is going to give you 5. And therefore she needs 5 of these deals, right? So she needs 5 times by £36. And that's going to give you £180. Okay, so that's chic decor. Then we can do the same thing for style papers. So I'll write it over here. Style papers. Style papers, you get 5 rolls for the normal price of £70, but you get 12% off. So you need 15 over 5. Will tell you how many of this deal you need. So that's going to give you 3. And then you do 3 multiplied by the price of 70, but you get 12% off. So you basically, the multiplier for this will be times 0.88, okay? Because that's the multiplier. If you got 12% discount, you pay 88% of the normal price. So this should come out as £184 and 80 pence. Okay, so you can clearly see then chic decor is cheaper, and that's what you'd put. Question 5, the table gives information about the lengths in centimeters of some pieces of string. Amos draws a frequency polygon for the information in the table. Write down 2 mistakes that Amos has made. So let's have a look at his polygon. We got to compare this with the graph. Okay, so looking at the graph, first of all, you should be able to notice if you look at the frequency axes, he's going in jumps of 10, but then he's missing one number. So from 30, he goes straight to 50, whereas he should have 40 over here instead and then go to 50. So he's missing that from the axes. Then let's also have another look through. So you can see that he plots it basically at the midpoint of each of his length columns, right? So 0 to 10, it appears on the 5 centimeter mark, right? But the problem is then if you look at the last point, 50, it doesn't appear at the midpoint. If he's plotting this 40 to 50 on, then it needs to appear at the 45 point, just like he's plotted at the midpoints for the other ones as well. Okay, so that's 2 mistakes there that you could write down. Question 6, Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed, give your answer in miles per hour. So for this question, we just need to remember our formula. Speed is equal to distance divided by time. And actually for the first part, we just want to work out the total distance. And then because you got Amy's time, if we had the distance and the time, that means we were able to divide through to get the speed. Okay, so let's try to work out the total distance that Jessica actually runs. Okay, so if you combine both of these, we'll get the distance. So she runs for 15 minutes at an average speed of 6 miles per hour. So again, if we basically rearrange this formula, we should get distance is equal to speed multiplied by time. So if we multiply speed by her time, we should get the distance. So 6 miles per hour multiplied by 15 minutes. But remember, because we're working in miles per hour, then our time measurement also needs to be in hours. So it's 15 minutes, which is going to be in hours, 15 divided by 60, okay, to get it as hours. And so if you multiply both of those together, you should get that she runs 1.5 miles in this leg. Then the second part, she runs 40 minutes. An average speed of 9 miles per hour. So we do the same thing. So you take the average speed 9, you multiply it by 40 divided by 60 to convert it into hours. And if you do that, you should get 6 miles. Okay. And therefore the total distance is going to be 1.5 plus 6, which is going to give you 7.5 miles. Okay. So nice and simple to get the total distance. And then we've got the time that Amy takes was 45 minutes. And we got our equation speed equals distance over time. So we take our total distance, 7.5, and we want to divide it through by the time taken, which was 45 minutes. But again, we need to convert this into hours. So we divide through by 60, and you should get 10 miles per hour. Okay, you can write that down, and you can see they want it in miles per hour in our final answer as well. Question 7, the diagram shows a rectangle stub. TQU and SRV are straight lines. All measurements are in centimeters. The area of trapezium QUVR is a centimeter squared, so that a equals 2x squared plus 20x. So to work out the area of the trapezium QUVR, which is this shaded section over here, what we can do is we can work out the area of the whole rectangle and then take away the area of our second trapezium TQRS, okay? So let's do that. So the more difficult one, I guess, is going to be the trapezium. So the area of trapezium TQRS is going to be equal to, well, you just want to use the formula for this. So we take the longer side, 4x, and we multiply that by 0.5. Then we multiply that by the sum of the other two sides, 2x plus 3x. Okay, so you can, it doesn't really matter what order you do this in, but basically it's 4x multiplied by half of the sum of the other two sides. And then if you work out what that is, so you have 4x divided by 2 is going to give you 2x multiplied by 5x. And so if you multiply those together, you should get 10x squared. Okay, so that's the trapezium TQRS. And then we want to work out the area of the rectangle TUVS. And so you just need to, again, use the formula. So this side will be 3x plus 5, and you want to multiply that by your 4x. So we can write that down, multiplied by 3x plus 5. And again, you can then just expand those sets of brackets. So 4x multiplied by 3x should give you 12x squared, plus by 4x times by 5 should give you 20x. Okay, perfect. And then the last thing you want to do is just take one away from the other. So just make sure you do it in the right order. So it's 12x squared plus 20x is your rectangle, and you want to take away your trapezium from that. So minus 10x squared. And so you should get 2x squared left over plus your 20x. Okay. And you can see that matches what we were asked to prove over here. Question 8. An electricity company charges the same fixed amount for each unit of electricity used. David uses this graph to work out the total cost of electricity he has used. Work out the gradient of these straight lines. So the easy way to do that is dy by dx. So you want to draw a big triangle as big as you can and work out the difference in y and divide that by the difference in x. So you can just choose 2 points because it's a straight line. So I'm going to just choose maybe some easy points to read off of. So let's just take this point, and then let's take a point over here. And so just read it off. Basically, the first point we have is going to be 17-ish. And if you look at what the scales would be on the y-axis, let's zoom all the way in. So we can see that this is going to be 18 because it's halfway between 16 and 20. And therefore, these are going to be jumps of 0.2, looks like 16.2, 0.4, 0.6, 0.8. Oh, no, looks like these are going to be jumps of 0.4. So 16.4, 0.8, 17.2, 17.6, 18, which makes sense. Okay, so now we worked out the scale is going up in 0.4s. So then we need to come across to our point over here. Just make sure you mark it on accurately. So you can see you've gone 2 up. So it's going to be 0.8 plus the 16. So this point is going to be 16.8, not 17. Then we do the same for our second point, which we drew over here. And now that I've zoomed in, I can draw a bit more accurately. So you can see this is, well, we should put the x coordinate as well. So 16.8, and the x coordinate we chose was 120. So you can write 120 over here, and technically you should be the x coordinate first. So I'll put it above, like there. 120 and 16.8, and over here we have 20. And then the y coordinate is, that would be 2, 2.4, 2.8. Okay, then you just need to work out the difference between those. So zoom all the way out. So the difference in the y values is going to be 16.8 and 2.8. So 16.8 minus 2.8. And then the difference in the x values is going to be 120 minus 20. And then go ahead and plug that into your calculator. You should get the gradient of 0.14. Okay, so that's what you can write down. What does the gradient of this line represent? So we just need to fit it to our actual explanation of what this graph is showing. And basically the gradient will tell us, essentially, since it starts at 0, it tells us the cost per unit of electricity as well. And in fact, even if it didn't start at 0, it would still be the same. Because it's consistent, we can just say cost per unit of electricity. Question 9, express this expression. So we've got a big square root and some powers in there as a power of 10. Okay, so the first thing we want to do is basically use the rules of indices to simplify this down. So I can see this expression on the bottom, 10 to the 150 times 10 to the 90. We can basically add the indices since they have the same base. If we add the indices, we get the equivalent just in one number. So 10 to the 150 times 10 to the 90, you just add them both together, you get 10 to the 240, right? 150 plus 90, 240. Then we can rewrite the expression 10 to the 360 over 10 to the 240, all square rooted. And when you're dividing these powers with the same base, then basically you can take away the indices. So 10 to the 360 minus 10 to the 10 to the 360 minus 240 is basically what you get. And so if you do that, you should get 10 to the 110. Sorry, 10 to the 120. And then let's add our square root back in. And then finally, you can say that when you have a square root, you can rewrite that as 10 to the 120 all multiplied by or raised to the power of a half. Okay, so that's another way to write a square root, is you raise something to the power of a half. And then again, you can use the rules of indices here. You got 10 to the 120 raised to the power of a half is basically the same as multiplying those two together. And so your final answer is going to be 10 to the 60. All right. Liam was asked to express 12 to the 50 all squared as a power of 12. Liam wrote 12 to the 50 squared equals 12 to the 50 squared equals 12 to the 2500. Liam's method is wrong. Explain why. So we just basically kind of explained it here. According to the rules of powers, 12 to the 50 squared, you don't want to square it. You need to actually use the rules of indices to multiply them together. Okay, so basically 12 to the 50 squared should be 12 to the 100, not 12 to the 2500. Okay, question 10. Jane bought a new car 3 years ago. At the end of the first year, the value of the car decreased by 12.5%. The value of the car then decreased by 10% each year for the next 2 years. At the end of the 3 years, the value of the car was £17,000 or £17,010. Work out the value of the car when Jane bought it 3 years ago. Okay, so it's a simple depreciation question. If you know how to do this question, it should be fairly okay. So we've got the end of the 3 years, the value was £17,010 and it decreased by 10% each year for the next 2 years. So the depreciation from the second to the third year was 10%. So we can work out what it would have been worth at the end of the second year by simply saying that £17,010 was actually 90% of the value at the beginning of the first year, remember, because it lost 10%. So if you divide through by 90 and multiply by 100, then we should get the value at the beginning of the second year, okay? At the end of the second year or the beginning of the third year. So if you do that in your calculator, you should get 18,900. And then you can do the same for the difference between the first year and the second year. So to get the value at the end of the first year or the start of the second year, then you do 18,900. And because that was also a depreciation of 10%, you do the same thing. Divide it by 90 times by 100. And so you should get 21,000 as your total at the end of the first year or start of the second year. Then to get the initial total, this time it decreased by 12.5% in the first year. So from the end of the first year to the start of the first year, you can do 18,900. And this time, because it decreased by 12.5%, your multiplier wouldn't be 90, it would be 87.5. Because it was worth 87.5% of the total at the beginning. Then multiply by 100 to get the total at the beginning. And sorry, this shouldn't be 18,900, it should be 21,000. So let's switch that out. And then you should get a final answer of £24,000. And you can write that down there. Okay, question 11. Raheem has 16 shirts, 5 pairs of jeans, 3 jackets. Raheem chooses an outfit to wear. An outfit is 1 shirt, 1 pair of jeans, and 1 jacket. Work out how many different outfits Raheem can choose. So when you have a question like this where you have different options, basically to get the total number of options, you just do 16. You just multiply them all together. So 16 multiplied by 5 multiplied by 3. Okay, and if you put that in your calculator, you should get 240. Question 12. ABC and ACD are right angled triangles and DC equals 8 centimeters. ADC is 45 degrees. ABC equals 20 degrees. Work out the length of AB. Okay, so the length AB is over here. And we can mark it on that this is AB. So this is what we're trying to find. So we've only got one angle here, so we probably do need a side as well. And if we have a side, and because this is a right angle triangle, we've got an angle, we can work out one of the sides, then we should be able to use trigonometry to work out the side AB. Okay, so then let's look at over here at the triangle ADC. And if you notice, this triangle is also a right angle triangle, and it has an angle here of 45 degrees. Now, according to our angles and triangles, we know that angles in a triangle have to add up to 180 degrees, which means that these two angles have to add up to 90 degrees, which means that this is also 45. And what you'll notice straight away, two angles are the same, therefore this is an isosceles triangle. Two angles are the same, right angle, this is an isosceles triangle, and that means that this is also 8 centimeters. So A to C is also going to be 8 centimeters. Now, if you notice what you said right at the beginning, because we've got an angle over here, if we work out one of the sides, we should be able to work out AB using trigonometry. So let's see what we've got here because it's a right angle triangle. So let's see what we've got here. We've got this angle and we have the side opposite the angle, and we're trying to work out the hypotenuse. So you should be able to identify, you need to use the sine rule here. So sine of the angle, or sine of 20, is going to be equal to the opposite over the hypotenuse. So 8 over the hypotenuse AB. And then a simple case of rearranging. AB is going to be equal to 8 divided by sine of 20. Okay, and if you put that into your calculator, you should get a final answer of 23.4, and it's going to be in centimeters for our side AB. And we just need to check, just when you put it in your calculator, make sure you round it to 3 significant figures. Okay, question 13. A and B are vectors such that A equals 2 minus 3 and 3A minus 2B is 8 minus 17. Find B as a column vector. So vector multiplication is very similar to normal multiplication, to be honest. And so this is basically an algebraic question. So we have A is 2 and minus 3. So therefore 3A is going to be equal to, you just multiply both by 3. So this becomes 6 and this becomes minus 9. And that minus 2B is going to be equal to 8 minus 17. So you can just basically take these and work out each on its own, right? And we shouldn't really write it like this, to be honest. You should write these in 2 separate steps. So 3A equals 6 minus 9. Okay. Then the next thing over here is if you do 6 minus, and we call it 2bx, we'll call this the x vector, is going to be equal to 8. And then minus 9 minus 2b, we'll call this the y vector, it's going to be equal to minus 17. So we got two individual equations here. We can just work out bx and by, where basically what we've done is we split b into this form, bx and by. Okay, that's just the way we've done it. You could do it a different way and call these different things. But anyway, if you do that, then you get 6 minus 2 bx equals 8. Therefore, let's solve this first one. So 2 bx is going to be equal to 6 minus 8. And therefore, bx is going to be 6 minus 8 over 2. And 6 minus 8 is just minus 2. So minus 2 over 2 equals minus 1. Okay. And then we could do the same thing for the other equation. So minus 9 minus 2 by equals minus 17. So therefore 2by equals minus 9 plus 17. And that should give you 8. And therefore by is equal to 8 over 2, which is 4. And so then we can write our vectors. Just make sure you put it in the right form, so the right order. So minus 1 and 4 according to the way we wrote it over here. Okay, next. 14 factorized fully, 4p squared minus 36. So this question, you do need to spot that is the difference of two squares over here. Okay, and so therefore it's just going to follow the standard formula. But what you should be also notice is you can simplify this by taking a factor of 4 out from both the 4p squared and the minus 36. And so if you do that, then you get p squared minus, and then 36 over 4 is a 9. And then you just do the difference of two squares classic formula with this section over here. And so if we go ahead and do that, then we get 4, we leave the 4 on the outside, and then we get a p minus 3, because you square root the 9, and a p plus 3, okay? And that is your answer there. Okay, show that m plus 4, 2m minus 5, and 3m plus 1 can be written in the form am cubed plus bm squared plus cm plus d. A, b, c, and d are integers. So basically, we just want to expand this all out. So let's go ahead and do that. So let's do it with the first one. So m multiplied by 2m is going to give you 2m squared. And then m multiplied by minus 5 is going to give you minus 5m. And then 4 multiplied by 2m is going to give you plus 8m. And then 4 multiplied by minus 5 is going to give you minus 20. And then you want to multiply all of that by 3m plus 1, because that's the one we haven't multiplied yet. So let's clean this up. So you get 2m squared minus 5m plus 8m. Well, that's going to give you a plus 3m minus 20. And multiply that by 3m plus 1. So let's take the 3m first. So 2m squared multiplied by 3m is going to give you 6m cubed, plus 3m multiplied by the 3m is going to give you 9m squared, plus minus 20 multiplied by the 3m, which is going to give you minus 60m. And then you do the same thing for the plus 1. And so because you're just multiplying by 1, it would just be this expression that we wrote in the first place over here. So we can add that on. So plus 2m squared plus 3m minus 20. And then the last step is basically just to clean this all up. And so you should get 6m cubed. There's no other m cubed, so that's fine. Then you have 9m squared and a 2m squared. So you want to combine both of those to get an 11m squared. And then you have a minus 60m plus a 3m. So you combine both of those to get a minus 57m. And then the last thing, you have a minus 20 on the end, and that stays the same. And then we've got it in the form we wanted, just like the question said over there. Question 15, P, Q, R, and S are 4 points on a circle. You've got PXR and SXQ are straight lines. Prove that the triangle PQX and triangle SRX are similar. This is a circle theorem question, which is always fun. So I think the easiest way to prove this, basically, you want to prove they're similar. To do that, basically, you can show that all the angles are the same. If all the angles are the same, that means that these two are similar. The lengths of the triangles could still be different, and they do look like they're different, but they would basically be scaled versions of each other, so they'd be similar. So the easiest one to get then to show that all the angles are the same is, I think, this middle one here. So you can say P to X to Q is equal to S to X to R, because these are basically opposite angles, okay? So that would be one, right? So over here, you'd say these are both opposite angles. Then you need to get the other two angles now to show that they are the same. So the next one you could say is angle QPX. So let's use a different color for this. So we get blue. So QPX is this angle over here. And QPX is going to be equal to RSX, which is this angle over here. And the reason that you'd say is the angles in the same segment are equal, or angles at the circumference subtended from the same arc or chord of a circle are equal. But basically, these are angles in the same segment, okay, because they're drawn with the same lines in the same segment, and therefore they are both equal. Then, to be honest, for the last point, you could say that these angles are equal for a couple of reasons. Again, same reason, right? SRX and PQX are equal because they're angles from the same segment, okay? Angles in the same segment. Or alternatively, you could say angles in a triangle add up to 180 degrees. So if the first two angles are the same, that means the third angle is also the same. And for that reason, the triangles are similar. Okay, so that's what you'd say. Question 16, P equals square root of 2e over f. E equals 6.8, correct to 1 decimal place. F is 0.05, 2 correct to 1 decimal. F is 0.05, correct to 1 significant figure. Work out the upper bound for the value of P. Give your answer correct to 3 significant figures. You must show all your working. So it's a bounds question. So to work out the upper bound of P, so we need to work out, because we're dividing 2e over f, then we want the upper bound of 2e, and we want the lower bound of f, okay? That will give us the largest possible number, and then we square root the largest possible number will give us the largest possible square root as well, okay? Right, so let's work out the bounds of e first. So e, because it's 6.8 correct to 1 decimal place, then it could be 6.85, and you round down to 6.8, or it could be 6.75, and you round up to 6.8. Technically, it would be a bit less, but by convention, we write 6.85. You guys should be familiar with that. Then we could do the same thing for f. So f, because it's correct to 1 significant figure, then this could be 0.055, or it could be as little as 0.045, and you round it up to 1 significant figure. Okay, so again, the same reasoning there. And then we already figured out that we want the upper bound over the lower bound, and that should be a b. So anyway, the upper bound over the lower bound. So you do 2e, which is going to be 2 times the upper bound of e, so 6.85, divided by f, which is the lower bound of f, 0.045, and square root all of that. And if you put that into your calculator, you should get 17.423 significant figures. Question 17, the table gives information about the distances in miles that some Year 10 students live from school. On the grid, draw a histogram for this information. Okay, so for histograms, we need frequency density, and then we also want have the class width as well to work out what that's going to be. So let's go ahead and add some columns to our table. So yeah, like we said, we want the class width over here. And then we also want the frequency density that we're going to work out. So the class width, and this is 1. And then 1 to 1.5 is 0.5. And then 1.5 to 2 is 0.5. And then 2 to 3 is 1. And then 3 to 5 is 2. So we worked out the class width for each of them. Then we can work out the frequency density due to the frequency divided by the class width. So this is still 90. And then we do 48 over 0.5. So that's basically the same as doubling it, which gives you 96. Then you do 22 over 0.5, and again, so that gives you 44. And then 8 over 1, which is 8. And then 12 over 2, which is 6. And so this would give you the frequency densities. Then we just basically plot our bars according to the distance and the frequency density. So 0 for 1, you'd plot a frequency density of 90. And so you'd have to go through and add on your some sensible axes as well. So I'll leave it here because I don't really have a ruler or anything, but it should be pretty simple for you guys to plot on once you've got these numbers. Okay, the histogram below shows information about the distances in miles that some Year 11 students live from school. The number of Year 11 students who live between 1 and 2 miles from school is n. Find an expression in terms of n for the number of Year 11 students who live between 3 and 5 miles from the school. So if we look between 1 and 2 miles, it's this bar over here. And if we look between 3 and 5 miles, it's this bar over here. So the number of students who lived between 1 and 2 miles was n. Okay, so this represents n number of students. And then between 3 and 5, we basically need to work out what that would represent as n. So we just need to basically work out the area of this bar. So 1 to 2, this is going to be a width of 1. And then the height, we can just basically count it, is 1.5 full blocks. And so basically this would come out as 1 times 1.5 or 1.5 blocks squared, if you like. Then we do the same thing over here. So 3 to 5, this had a height of, looks like 0.3. And the width is 2. And so this has an area of 0.6 blocks squared, if you like. And so then if this represents 1.5, then basically you just do 0.6 over 1.5 to get the fraction, multiply that by n, and that would give you the expression for n. And so this simplifies down to 0.4n. Question 18, here's a prism. Here's a prism ABCD SPQR, quite a mouthful. The base ABCD of the prism is a square of side 40 centimeters, and T is a point on BC such that BT to TC is 4 to 3. Again, a lot of words, but let's just work out what that means. So the base is a square with size 40 centimeters, so what they drew on there, and T is a point on BC such that BT to TC, so BT to TC is 4 to 3. So this is if this whole length was, well, if this is x, in fact, if this is 4x, then this would be 3x. Basically, that's what they're saying. The cross-section of the prism is in the shape of a trapezium of area 147 centimeters squared. So that is the cross-section. If you take a cross-section through it, then it's the shape of a trapezium, which we know is basically this thing here. And that has an area of 147 centimeters squared. And the final point they give us is CR equals 12 centimeters. So C to R, which is this top point over here, and that's drawn on for us 12 centimeters. Find the size of the angle between the line ST and the base ABCD. Give your answer correct to 1 decimal place. So ST is the dotted line that they drew, and you want to find the size of the angle between that and the base ABCD. So basically, essentially, it would be this angle over here. Okay, so for this, let's try to draw a few extra triangles on essentially to help us work this out. So essentially to find this angle, the chances are we're going to need this Didn't quite draw that right, but essentially we're going to need this side, t to d basically. And to get that side, then basically we can do it if we were to know the other two sides. So this side over here is actually 14 as well, because remember this is a square. So we know already that this is 14. I'll just clean that up. And then t to c we can work out, right? So we already said this ratio of 4 to 3. And because b to c is a square, or it's a side of a square, it's also going to be 14. So it'd just be 14. This total would be 7x. So 14 divided by 7 multiplied by 3 would give you the length t to c. Okay, so if you work that, then that should give you 6. So then to work out the length t to d, we've got two sides and we recognize that this is going to be a right angle. So this is a right angle triangle. So we can use Pythagoras. We've got two sides we want to work out. The next side, it happens to be the longest side. So let's come down here. So c2 t was 6, so 6 squared plus 14 squared, which was the length of the other side, all square rooted will give you the length of the side t to t. And so if you put that in your calculator, you should get 15.2 and sort of carries on. And keep all the decimal places for now because we're not going to round it yet. And in fact, it would be even better if you just wrote this. Some calculators might do it. They might write this as 2 root 58. Okay, in which case you just leave it like that, and that's perfectly valid as well and more accurate. Then essentially we want to find the other side. If you have the other side, then we should have two sides and can work out the size of the angle. So if we have d to t, then the one that's missing is s to d, which is this side here. And so to get that side, then essentially we have the area of the trapezium, and so we can use that along with our other sides. So we've got 12 centimeters. We know that this is 14. We know the total area, so we should be able to work out what this side would be if you use our formula for area of a trapezium. So remember, the area is equal to 147. So 147 is going to be equal to a half multiplied by the sum of the two shorter sides. So 12 plus whatever SD is, and then multiplied by the flat side at the bottom, 14. And that should give you 147. So now we just need to rearrange this basically for SD. So let's go ahead and do that. So 147, and we're going to have to divide through by a half, which is the same as actually multiplying by 2. And then you want to divide through by 14. And then you should be left with 12 plus SD. So you take off 12 to get the SD on its own. Okay, you could do that in a few steps. So I've just done it in one step there. And so you should get then that SD equals to 9. So now you have the side SD is 9. The side dt is 2 root 58, which we worked out over here. And then we can just work out the angle. So tan of the angle is equal to opposite over adjacent. Remember, we're working with a right angle triangle, so we can use our trigonometry equations. So this is the angle, and this is the opposite, this is the adjacent. And we've worked out what each of those are now, so we can just work this out. So I will just make a bit of space. So tan theta, we'll call it theta, is going to be equal to opposite, which was SD, which came out to 9, over adjacent, which was 2 root 58, and then basically inverse tan that to work out theta. And then you should get a theta of 30.6 if you round it to the 1 decimal place. Okay, so that's how you do that. Question 19, show that 3x over x plus 2 minus 2x plus 1 over x minus 2 minus 1 can be written in the form x plus b over x squared minus 4, where a and b are integers. So basically, to do this question, what you want to do is get them all to have the same denominator, x squared minus 4. And then when they have that, then you can just add and take away just like normal, like you would with fractions, which have the same denominator. And so to work out how to do this, basically, whatever you do to the top, you can do to the bottom, you get the same fraction. As long as you remember that, then you can manipulate the fraction any way you want. So let's take this first one, 3x over x plus 2. And essentially, we need to work out what do we need to multiply x plus 2 by to get x squared minus 4. And so to do that, you would just have to multiply it by x minus 2, basically. And so you multiply the top by x minus 2 as well, and the bottom by x minus 2. And what you end up with is 3x squared minus 6x. This is multiplying the top. And divide that through by x plus 2, x minus 2, which is the difference of two squares that comes out to x squared minus 4, just like we wanted. Okay, and then you can do the same thing for the second one, 2x plus 1. So we know how to do it now. So 2x plus 1 over x minus 2. And basically it's just very similar to the other one, but you do x plus 2 instead of x minus 2. So that multiplied by x plus 2. And you need to multiply both the top and the bottom, okay? And again, very similar. So if you do that, you get 2x squared plus 4x plus x, so that's 5x plus 2, all divided by x squared minus 4, which is what you wanted. And then you do the same thing for the last one. So the last one is just minus 1. And so this would just come out to basically x squared minus 4 over x squared minus 4, but minus, right? So the last one is just minus x squared minus 4 over x squared minus 4. Then you just need to combine all of these. So now because they all have the same denominator, you can just work with the numerators and then put them all over the same denominator. So let's write this all out down here. So I'm just going to grab 3x squared minus 6. That's the first numerator. Second numerator was 2x squared plus 5x plus 2. So add that one. So, and it is actually you're minusing one from the other. So this should be minus 2x squared minus 5x minus 2. And the last one is minus x squared minus 4. Okay. And that's your big long numerator that you should get. And in fact, just be careful here because this is a minus. And so it will be minus x squared plus 4 because you're minusing a minus. If you write it out like this, then you should write it with a plus 4. And then basically what you need to do is clean that all up. So what you should notice is the 3x squared is cancelled out by the minus 2x squared and the minus x squared. So then you are left with simply minus 5x. And I wrote this wrong. So that should be minus 6x, not minus 6. Just copied it down wrong. So correct that. Then you should get minus 11x because you combine those two. And then plus 2 should be your numerator. And this comes all under the same denominator, x squared minus 4. And I think that is what it asks for. Yeah, x plus b over x squared minus 4, where a and b are integers. And there's your form there with the two integers. Okay, question 20. The profit made by a shop increases each year. The profit made by the shop in year n is Pn pounds. Given that the profit made by the shop in the next year is Pn plus £1, then Pn plus 1 equals a Pn plus 800, where a is a constant. The table shows the profit made by the shop in 2018 and in 2019. Work out the profit predicted to be made by the shop in 2021. So the first thing we can do here is actually work out the constant a, because we have the profit made by the shop in the nth year and the profit made by the shop in the nth plus 1 year, because the nth year you can take as 2018 and the nth plus 1 year you can take as 2019. So if you plug these into our formula, then we should get that 29,600 is equal to a multiplied by 24,000, or we can even just write this quickly as 24,000a, and that was plus 800. Okay, so if you rearrange for a, then you should get 29,600 minus the 800 divide through by 24,000. And then if you work that out, then you should get that a is equal to 1.2. And then the question wants us to work out the profit in 2021. So to do that, we need to work out profit in 2020 first. And so we can use our formula to do that. So the profit in 2020, and we'll call this 2020, P 2020, is equal to the profit made in 2019 multiplied by A. So 2019 profit was 29,600, A was 1.2. So 1.2 times 29,600, and then you want to add on the 800 as well. So you can see it's not that hard, or not as hard as it looks. And so if you work that out, you should get 36,320. And then the profit made for 2021 is just going to be, you just do the same thing, but you plug in the profit from the previous year instead. So 1.2 multiplied by what we just worked out, 36,320 plus the 800. And if you do that, you should get an answer of £44,384. Ray has 9 cards numbered 1 to 9. Ray takes at random 3 of these cards. He works out the sum of the numbers on the 3 cards and records the result. Work out the probability that the result is an even number. So to work this out, basically we need to identify that if you want an even number, when you multiply 3 different numbers together, all of those numbers need to be even. Now the probability of picking an even number, then you got 2, you got 4, you have a 6 and an 8. So you have 4 out of a possible 9 cards, right? You got 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 out of 9 is the probability of picking an even card at the beginning. But remember that actually in the following picks, there's less cards. And in theory, if you've picked an even number already, there will be one less even card as well. So on the second pick, the chances of picking an even number, because there's going to be 3 even cards left, it will be 3. And the total number of cards has gone down to 8, right? So the probability will be 3 over 8 on the second one. On the third pick, again, the same thing happens. Because you've picked 2 even numbers already, then there's only 2 left. And in the total, there's only 7 cards left, okay? And then to get the probability of picking each of those, right? You want to pick an even number on the first go, the second go, and the third go. Then you just multiply those 3 probabilities together to get the total probability, right? Okay, so that's one way of getting your even number. The other way is if you have 2 odd numbers and you multiply it by an even number, you also get an even number, okay? So yeah, don't discount that. So you could do even, odd, odd, where you pick an even number and then 2 odd numbers. And also the other way you could do it is you could pick odd, odd, even as well. So for even or odd, you do a very similar thing to what we explained before. So to pick an even number at the beginning, chances are 4 over 9. Then on the second go, you want to pick an odd, but you've decreased the number of cards by 1. So remember the number of odd numbers is 5, right? And so the total number is 8, so 5 over 8. Then you do the same thing over here, and you pick an odd again, so you decrease the odd numbers, and you decrease the total number by 1, so 4 over 7. Then similar thing for this one, where you do odd, odd, even, and the chance of picking odd at the beginning is 5 over 9. Remember, this is a different probability if you pick odd at the beginning versus odd at the end, because there's a different number of cards, so you need to take this into account, right? So 5 over 9, then you pick odd again, this time you get 4 over 8 because you decrease 1 from each of those. And then the last one you get is then picking the odd number, so you get 4, because there's still 4 even numbers in there, but the total is 7, okay? And then therefore that's all the different ways you can do it. And then if you basically work those all out and add them together, you should get a final answer of 11 out of 21, right? Because then we just need to add them all up to get the total probability of picking a result that results in an even number. Okay, question 22, which is the final question in this paper. L is a straight line with the equation y equals 2x minus 5. C is a graph with the equation y squared equals 6x minus 25x minus 8. Using algebra, find the coordinates of the points of intersection L and C. You must show all your working. So for points of intersection, basically we need to have y and x in both of these formulas be the same. So if we assume they're the same, then we can eliminate accordingly, right? So if you say y is the same for both of them, then what we can write is that 2x minus 5 all squared is going to be equal to y squared, which is equal to 6x squared minus 25x minus 8. Okay, so you can see basically what we did there, which was combine both of these by squaring this one. Okay, so then we can take this and expand it out. And so if you expand this side out, then you should get 4x squared minus 20x plus 25 is equal to 6x squared minus 25x minus 8. And so, yeah, just remember to expand out properly. So you can write this out to help you. 2x minus 5 all squared, 4x squared, and then 2x times by minus 5, 2x times by minus 5 again, you get minus 20x. And then minus 5 times by minus 5, you should get plus 25, okay? So then you get it into this form. And so here you can just simplify down. So 6x squared minus 4x squared should give you 2x squared. And then, so I'm just taking it to this side basically. And then minus 25x plus 20x should give you minus 5x. And then minus 8 minus 25 should give you minus 33. And then that's now our simplified formula. So what we can do is then work out what x would be if we set this equal to 0. So this does actually factorize down. So you could put it in brackets, 2x in one bracket and x in the other bracket. And what goes inside, you should get 2x minus 11 and then x plus 3 is equal to 0. And so then your two answers for x, one answer is going to be x equals minus 3. And the other answer is going to be x equals 11 over 2. And now that we have values for x, we can simply plug that into any of these equations. So I would recommend the top one because it's a bit easier to work out values for y. So let's go ahead and do that. So your y1 is going to be equal to, well, let's plug in -3 first. So 2x minus 5. So 2 times -3 minus the 5. And if you do that, you should get that y is -11. And therefore, your first set of coordinates for the intersection point would be -3 for the x-coordinate, -11 for the y-coordinate. And then you can work out y2, same thing. You do 2 times by 11 over 2 and minus the 5 again. So you just get 11 minus 5, and that should give you 6. So over here, you have your first coordinate 11 over 2, and your y-coordinate is going to be 6. And that's your points of intersection. Okay, so not too bad question to finish off with. Right, so that is it for this paper. Hopefully that was useful. You use that as a kind of walkthrough and a guide. And yeah, any questions, leave it down in the comments, and I'll see you in the next one.